Hey guys, today we are going to learn all about dependent events. By the end of this lesson, you will be able to find the probability of compound events, specifically dependent events. In our last lesson, we talked about independent events where one event did not affect the other. So the outcomes were independent. In this lesson, our outcomes are going to be dependent. And we'll talk about what that means on the next slide. Go ahead and get out your notes and be ready to learn. So dependent events are events that are dependent on one another. And this means when the outcome of one event impacts the outcome of another. When that happens, it is called a dependent event. Next, we're going to read these situations and determine if they are independent or dependent events. Remember in our last lesson, we looked at independent events, and that's where we were maybe taking something out and then putting it back in. So with that first example, we were drawing out of the 8 cards, and I would take one out, and then I would put that card right back in so that we still had 8 cards. Or we might have 2 totally separate things happening, like some of our last examples, we were flipping a coin and rolling a die. And so those didn't really have anything to do with each other and didn't affect each other. With a dependent event, we might take the card out and then not put it back in. So like in that first example, I had 8 cards to begin with, but if I take a card out and keep it, the next event would only have a total of 7 cards. So we'd have a different probability happening there. So looking at this first example, it says, flipping 2 coins results in one landing on heads and one landing on tails. In this problem, since we have 2 different events happening and they don't affect each other's outcome, since they are 2 separate coins, these are independent events. The next one says the captain of the football team is selected and then the co-captain is selected. So if you think about a football team, let's just say we have 25 kids on the football team. And we select the captain. And then the captain is taken out because you can't be a captain and a co-captain. After I take the one captain out of the 25, now there's only 24 kids left that could be selected as co-captain. So since that kid being taken out happened, dependent event. Number 3 says you draw a joker from a deck of cards and then you draw an ace. Think about this problem and decide, is it independent or dependent? This event is dependent since it doesn't say anything about once I take a card out that I'm putting it back. We're going to understand that I take that card out and I keep it. The next problem says you draw a queen from a deck of cards, replace it, and then draw a 10. Let me know, is this independent or dependent? Since in this problem we are replacing the card, we're going to have the same amount of cards each time that I draw, so this is an independent event. The final problem, a coin is flipped and a number cube is rolled. Let me know, is this independent or dependent? Since 2 different things are happening and it doesn't really affect our total, this is also an independent event. Now that we've looked at some examples of independent and dependent events, let's talk about what independent probability and dependent probability are. To review, independent probability is the probability of events A and B occurring, but in this we take the probability of A and then we multiply by the probability of B. Dependent probability, something has to happen first and the order does matter. So for the probability of A and B occurring, first we would have the probability of A and then we would have the probability of B after A has already happened. We're going to use our understanding of independent and dependent events to answer the questions below. Question 6 says, Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. What is the probability that Neil selects a bone and then a ball? So in this problem, it doesn't say anything about putting one back. Since one is not being put back, this is going to be a dependent event. So first, he chooses one and then he chooses another. This event, it says, what is the probability that Neil selects a bone and then a ball? So when I look through the treats down here, there are 3 bones. 1, 2, 3. So the probability of selecting a bone is 3 out of 7 because there are 7 total treats. Then we're going to keep that bone and we're going to choose something else. And then it wants to know what is the probability of choosing a ball. So out of these 7 items, there are 2 balls. But we took one of these bones away. So this bone is no longer here. So now we only have 6 items. So we've got a 2 out of 6 chance for that ball. And now we just multiply straight across. 3 times 2 is 6. 7 times 6 is 42. And then, since both of these can be divided by 6, this ends up reducing to a 1 out of 7 chance. Question 7 says, Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? So, in this problem, since it doesn't say anything about her taking a candle and putting it back, it's going to be a dependent event. For our first draw, there are the 2 polka dotted candles and there are 5 total candles. So the probability of first drawing a polka dot candle is 2 out of 5. For our next event, though, we're going to pretend like we have already gotten that polka dot candle out, and we're not putting it back in. So now I'm left with 4 candles, and only one of the remaining candles is a polka dot candle. So the chance of that happening is 1 out of 4. So now to find the probability of this compound event, 2 times 1 is 2, and 5 times 4 is 20. So this reduces to 1 out of 10. On the back it says, read each situation carefully and determine if the events are independent or dependent and find the probability of the events occurring. So it says Miss Moore is doing laundry and has various pieces of clothing in her laundry basket. It wants to know on number 8, what is the probability of selecting a top and then selecting a bottom? So for this one, it doesn't say anything about putting that item back into the laundry basket. So this is going to be a dependent event. First of all, we need to figure out how many items are there in the laundry basket. So when you count the items in the laundry basket, you've got to remember, if I'm just drawing something out, these socks aren't pairs, so they don't go together. They're each an independent item or a separate item. So for our first draw out of this laundry basket, there's going to be a total of 16 items that I could grab. And first it wants to know about selecting a top. So when I look in this laundry basket, there's only 1 top. So the probability of selecting a top is 1 out of 16. Then our next event, we already said we're going to take that top out and we're going to keep it. So now we're only going to have 15 items left in the laundry basket. And this time it wants to know about selecting bottom or a bottom. So that could be these pants or the skirt. So in this case, we've got 5 out of our 15 items that we're wanting to select. So now we're going to find this probability. 1 times 5 is 5, and 16 times 15 is 240. Well, I know these are both divisible by 5, so when I divide by 5 on the top and the bottom, I get a simplified fraction of 1 out of 48. Number 9 says, what is the probability of selecting a striped sock, replacing it, and then selecting another striped sock? So in this problem, we are replacing it, so that tells me that this is going to be an independent event. For our first draw, we still have 16 items in the laundry basket. And we're looking, and I can see that there are a total of 5 striped socks. So we've got 5 out of 16. For our second time, we're going to put that sock back in, and then we've still got 16 items in our clothing basket, and there are still 5 striped socks in the laundry basket. Multiply that, I have a 25 out of 256 probability of selecting a striped sock, replacing it, and then selecting another striped sock. I want you to go ahead and try number 10 all by yourself. Number 10 says, what is the probability of selecting a towel, replacing it, and then selecting another towel? First of all, this is an independent event since we are taking something out, putting it back, and then doing it again. So in this problem, there's only 1 towel out of the 16 items in the laundry basket, so the probability of the first event is 1 out of 16, and the probability of the next event is also 1 out of 16, so this is a 1 out of 256 probability. Let's look at number 11. It says, what is the probability of selecting a skirt and a top, one choice after another? Go ahead and try this on your own. Is this an independent or a dependent event? Since this one doesn't say anything about putting the item back, this is a dependent event. We're going to take the top out, keep it, and then we're going to take a skirt out. Vice versa, probability A is a skirt and probability B is the top. The probability of the first event happening is 2 out of 16. There are 2 skirts and still 16 items in the laundry basket. And then the second event is 1 out of 15 since there is 1 shirt, and now we only have 15 items since we took our last item out. This leaves us with a 2 out of 24 probability, which then reduces to 1 out of 120. Now that you've made it to the end of the lesson, let me know. Would you rather play a card game or a board game? In this lesson about dependent events, we looked at finding the probability of compound events. We would find the probability of one event and then determine if it was independent or dependent so that we could find the probability of the second event happening, and those 2 events happening together is a compound event. In some of our problems, it would say that we took something out and then replaced it. When that item is being replaced, that usually indicates an independent event, or when 2 events are happening that don't really have anything to do with each other, like rolling a die and flipping a coin. Those are independent events. One does not affect the other. However, when we have an event that does affect the other, so when we draw a card out and we keep it, then our total is changed for the second event, and that is called a dependent event. Let me know if you have any questions. Bye, guys.